backside of the slope field sheet, we have a couple of graphs here. All right, we're given the slope field. We have to identify the diffie-q that produces this slope field. So, what are we looking at? Well, see, key in on the zero slopes. We can see the zero slopes because they're the horizontal lines, and we can see that we have horizontal lines, or zero slopes, going right along that line right there. That line that I'm tracing over, I'm not actually drawing with the red pen, is the y equals the opposite of x line. Alright, so when y is equal to the opposite of x, the result will be 0. Well, there's only x here, there's no y at all. That means that we're going to have repetition vertically. There's no vertical repetition on this, that's out. Same thing here, this is only an x term in our dy dx. So therefore we need repetition vertically. We don't have that. That's out. Okay, go to E. E has just y in it. So what we're looking at is repetition horizontally. That is definitely not the case as we move horizontally across any row of the graph. That's out. So it's one of these two. Now, if x is equal to the opposite of, or y is equal to the opposite of x, then that would give us -1 right here. Right? If y was the opposite of x, we'd have x over the opposite of x, -1. Every single slope would have to be -1. That's definitely not the case. That one's out, which means this is our answer. But lo and behold, if y is the opposite of x, then we have x plus the opposite of x, which, oh, by the way, happens to be 0. That's the answer we're looking for. So we're focusing on the zero slopes. Now, unfortunately, that type of situation doesn't always work. Because if we look here, we see our zero slopes are right along the y-axis. All right, the y-axis is the line x equals 0. That means that when x is 0, the derivative is 0. Well, in every single possibility, the numerator will be 0 when x is 0. So that doesn't help us at all. So now we've got to start looking at positives and negatives, okay? Because we see x over y in every single case, except sometimes things are positive, sometimes they're negative. Let's focus in on quadrant number 3. Notice that all the slopes in here are negative, all right? So x is negative, y is negative, and the derivative is also going to be negative because we can see negative slopes everywhere, all right? Well, let's look at option A. If x is negative and y is negative, don't we have a negative divided by a negative? And a negative divided by a negative is a positive. But the derivative has to be negative. So that's out. Okay. Same thing right here. If x is negative and y is negative, a negative squared is a positive. A negative squared is a positive. A positive divided by a positive is a positive. But we have negatives. That's out. So basically, we're looking at something now down to these three. Well, let's go to C. If x is negative and y is negative, what's a negative cubed? That's right, it's negative. A negative divided by a negative is a positive. But again, our derivative must be negative. That's out. Okay, so now we get to D. If x is negative and y is negative, a negative squared is positive. The positive divided by a negative is a negative. So this is a possibility. If we look at E, x cubed, all right, a negative cubed is a negative squared is a positive, a negative divided by a positive is a negative. So it's either D or E, but we have to go somewhere else now. All right, well, let's move over to quadrant number 4. Let's see if that helps us out. Okay, in quadrant number 4 now, this is no longer the case. Now x is positive and y is negative. But look at all the slopes. dy dx, that's going to be positive as well. So dy dx is positive, x is positive, y is negative. All right, let's plug something in. If x is positive, all right, a positive squared is a positive, y is negative, a positive divided by a negative is a negative. But dy dx has to be positive. So it seems like D is out and our answer is E. Let's verify that. Okay, get rid of that. That's from the previous part. X is positive. A positive cubed is a positive. Y is negative. A negative squared is also a positive. And a positive divided by a positive is a positive. So this one does in fact check out. The answer is E. Okay, now it's slightly different for number 3. Here we have a slope field representing a Diffie-Q, and this time we have to pick the solution, all right, to the Diffie-Q, which means that all of our answers are y equals, as opposed to the previous problem where all of the answers were dy dx equals. In these cases, we had to pick the differential equation. Now we have to pick the solution. When you're trying to pick the solution, the goal is to find the graph within the picture. Okay, so what we have here, you can see we have some kind of parabolic shape happening. Okay, negative slopes leading to slightly less negative slopes, leading to zero slopes, leading to positive slopes, leading to even larger slopes. Okay, so we're looking at some kind of parabola here. We need a function in which the highest exponent is a square. Nope, that's out. And besides, the square root of x. If we were looking for the square root of x, we would need to see our slopes leading us in this manner. All right, x cubed plus 12x. That a cubic slope does this. That's definitely not happening. Okay, x to the 3x to the negative 2. So that's 3 over x squared. All right, well, 3 over x squared, now we've got to start worrying about what happens when x is 0. All right, and we have to have an undefined slope. Well, it's hard to see, but there actually are slopes here, which cancels out c. Y equals 4x minus 7. That's a line. We definitely don't have a line here, but we do have a quadratic. All right, so our answer is going to be A, because we see the parabola being formed by the slopes, so we're looking for a function which creates a parabola, and a quadratic function will create a parabola.